So I've been asked to do a couple of problems from the Solving Proportions and Similar Triangles Involving Quadratics worksheets. And this comes off of the second worksheet. So my worksheet has a bunch of stuff written all over it. So this is basically, I just got these out of the assignments link on my website. And here's number 7. And here's number 8. So the first thing I'm going to do is I'm going to draw the diagrams because I don't have a clean sheet. So for number 7, we have a circle, and in that circle it looks like we have 2 triangles, something like this. You're told that angle B is congruent to angle C. You're also told that angle A is congruent to angle D. Now, the worksheet did not come out perfectly. So there's like a little mistake here. Those look like zeros. Those should probably be those double arcs. Okay. So right away I know that I've got 2 angles in one triangle congruent to 2 angles in another triangle. Therefore, I know that the 2 triangles are similar. I also know that angle E then will be congruent to itself either by vertical angles or by the triangle sum theorem. So if these 2 angles congruent to those 2 angles and everything adds up to 180, then those 2 angles have to be congruent. Okay, I'm also given that BE is 6 and ED is 6. And I'm also given that x plus 5 is equal to x. Now, to help me set up everything, I'm going to write out a similarity statement so that I make sure that I have things in the right order. So I know, for example, that triangle BAE will be similar to triangle. Okay, so B corresponds with C, A corresponds with D. So we'll go C, D, E. Okay, so basically what I want to find here is the length of EC, which is what my x is. And in order to do that, I'm going to set up a proportion. I'm going to go with triangle ABE on top and triangle CDE on the bottom when I set up my proportion. So here's my proportion. Let's see, I've got some sides that I definitely know. So BE is 6. So that's from triangle ABE, so I'm going to put that on top. Now, what side does that correspond with? Well, when I look at B and E here, they're on the outsides of my similarity statement, right? And since I set up my similarity statement correctly, CE will also will be the corresponding side with BE. Okay, so CE is what I need. So CE is X. That can be kind of tricky because they kind of trick you and make these 2 exactly the same. So you think, oh, those 2 are corresponding sides. But in reality, the corresponding sides go right on top of each other, right? So I could like flip this triangle over and put C on top of B and D on top of A, and E would go on top of itself. Okay, so then I need another side. I need to involve X. Let's see, so X is CE. Oops, I already did that. Never mind. How about, let's do ED, because that's definitely a value. So let's see here. I've got ED will go with EA. So ED goes on the bottom, that's 6. And EA is over here, which is x plus 5. See how those were like in corresponding positions? So I know that that's how that works. And then I'm going to cross multiply and solve my proportion. So I'm going to have x times x plus 5 equals 36. Or x squared plus 5x equals 36. It's a quadratic, so you want to get everything onto one side. So I'm going to subtract 36 from both sides. I need factors of 36. That'll give me 5. Well, that's 9 and 4. So I have x and 9, x and 4. And then remember, you want your inners and outers to add up to that 5x. So if you don't see it right away, go ahead and do this. But to get a positive 5x, I would need a positive 9x and a negative 4x. So the 4 gets the negative, the 9 gets the positive. Not done yet. I got to still solve this. So x plus 9 will equal 0. or x minus 4 will equal 0. I'm going to subtract 9 from both sides. I'll get x equals negative 9. Add 4 to both sides, and I'll get x equals 4. Okay, so now it's time to use your brain. Which of these doesn't make sense? Because one of them does not make sense. If I'm looking for EC, can it be negative? Well, the side of a triangle cannot be negative. Okay, so we're going to throw that one out. That's our extraneous solution. That's our correct solution. So we know that the length of EC is equal to 4. Okay, let's do 8 next. That's the one just below it. So we got another one of these problems that look like, when I look at it, I can see the two triangles, and hopefully you can too. So CDE appears to be one triangle, and then CAB appears to be another triangle. I'm just going to write down everything that I have. And if this was you were copying this out of a book, you definitely want to draw the diagram. All right, so because it's on your worksheet, you don't have to draw it. All right, so the question is, we want to find the value or values of x so that DE is parallel to AB. Well, if DE is parallel to AB, then we know that, well, first of all, we know that we have a couple pairs of corresponding angles, right? We have two lines cut by a transversal. So this angle and this angle are corresponding angles. Now, if these two lines are parallel, then these two corresponding angles are going to be congruent. And the same would be true here. These two angles will also be congruent because they're corresponding angles, they're in corresponding positions, and these two lines are parallel, or if they're parallel, okay? All right, so can you see then that I have two triangles? The smaller triangle, which I'll make yellow, and the larger triangle, which I'll make pink. So how about I'll go, when I write my proportions right now, I'll go small over big. And the only way that you're going to be able to figure out what x is by basically you're saying, if these two lines are parallel, then I know corresponding angles are congruent, and by angle-angle similarity theorem, the two triangles are going to be similar. Okay, so taking my smaller triangle, well, I already know the sides of those, the side lengths. I don't know x, that's what I'm going to solve for. But I don't really have an expression for the bigger triangle side lengths. So for example, CA. All right, but CA is basically made up of CD and DA. So if I add those together, let's say I get 3x minus 19 plus x minus 3. Or in other words, 4x minus 22. So that is CA. And the same can be true on this other side. Basically, CB is going to be made up of CE and EB. So we're going to do 4 plus x minus 4, which is x, and that is your CB. All right, so I'm going to set up a proportion so that I can solve for x and figure out what x should be. Okay. So, how about I'll just go, I said I was going to do small over big, so I'll do x minus 3 over CA, which is 4x minus 22. And then over here, I'll do a similar small, which is 4, over the larger CB, which is just x. And then I'm going to cross multiply and solve for x. So I'm going to have 4 times 4x minus 22 equals x times x minus 3, or 16x minus 88 equals x squared minus 3x. Quadratic, so we're going to get everything onto one side, and I always keep my x squared term positive. So I'm going to subtract the 16x and add the 88 from both sides. Oops. 16x can be subtracted from 3x. All right, so let's see. We're going to have 0 equals x squared minus 19x plus 88. Factors of 88, that'll give you 19. That's 11 and 8. So I'm going to have x and 11, x and 8, and then I'll figure out my signs by looking at the inners and outers. So 11x, 8x, I need negative 19x. So what should my signs be? Well, in order to add these up and get a negative 19, they both have to be negative. Which makes sense because my last term is positive. Negative times negative would give me positive. Now, using zero product property, I'll set both of these equal to 0. So I get x equals 11 and x equals 8. So I have two answers. Well, let's double check that both of these answers make sense. If not, we'll throw one of them away. So if I take 11 and I plug it in for EB, for example, I get 7. CB would be 11. This would be 8. If I plug in, that would be 33 minus 19, which is a positive number. So we're good. How about x equals 8? Same thing. So here I'd have 24 minus 19, which is 5. 8 minus 3, which is 5. 4 here and 4 there. So we're totally, or sorry, 8 there, not 4. So we're totally good. So we can actually have two solutions for this one.